So this is a question from IIT JEE Advanced 2011. The question is from the chapter projectile. Here is the question. A train is moving along a straight line with a constant acceleration a, and a boy is standing in the train. He throws a ball in the forward direction with a speed of 10 meter per second with respect to the train. Okay, at an angle of 60 degree, right? The boy has to move forward 1.15 meter inside the train to catch the ball back at the initial height. We have to find what is the acceleration of the train. Okay, so guys, here is the train. Let us suppose this is our train. Okay, and this train is moving in the forward direction with an acceleration a. Let us pause, right? And here is a boy, like this is a boy. Let us suppose this is the boy standing here, and this boy is throwing a ball. This boy is throwing a ball with a speed of, let us suppose u is equal to 10 meter per second with respect to the train. Okay, at an angle of 60 degree, right? So in the frame reference of the train, let us suppose this ball will be moving like this. In the frame reference of this train, and to catch this ball, this boy has to move a distance of this 1.15 meter. 1.15 meter at the same level. Okay, that is what means. First we'll have to find out in what is the time period of this ball that it remains in the air in the frame reference of this train. So from the basic projectile formula we can use here. I will draw the separate diagram. This is our ball, and this is the velocity u, that is 10 meter per second. Okay, and this is the angle theta, right? So its horizontal component of the velocity will be u cos theta, that will be 10 into cos 60, that will be equal to 5 meter per second. So this is the horizontal component of the velocity, and similarly the vertical component of the velocity will be that is equal to 10 into sine 60, that will be equal to 10 root 3 by 2, that is equal to 5 root 3 meter per second. Okay, and also we know that there is an acceleration acting, that is due to the earth, acceleration due to gravity, that we can take 10 meter per second square, right? So for the vertical motion only, here if I suppose, let us suppose that for vertical motion, what is the time period of the ball that it remains in the air? Okay, so that time period will be equal to, as we already know the formula for the time period, that formula will be equal to that t will be equal to 2 into velocity of the ball in the y direction, that means in vertical direction, divided by g. This will be the time period. You can here I can put the value of vy. Vy will be equal to similar, that vertical component 5 root 3 meter per second. Okay, so our time period will be equal to 2 into 5 root 3 divided by 10. So that will be equal to root 3 seconds. Okay, so this is root 3 second. So our time period is equal to root 3 seconds. This means what? The ball is being in the air for a time period of root 3 seconds. Okay. So here if I consider the situation again, in the frame reference of the train, in the frame reference of the train, in the frame reference of the train, frame reference of the train, that our train is moving with an acceleration of a in the forward direction. So this train is moving with an acceleration in the forward direction, that value is a. If I observe this ball will be having an acceleration of minus a in negative x direction. So let us suppose this is the ball and it is moving like this, that projectile motion. So if I consider only the x direction, that is the horizontal direction, for horizontal direction, here let us suppose t is equal to 0, the ball is being projected, and at t is equal to root 3 seconds the ball is in contact with the train. Okay. So in horizontal direction there will be an acceleration of the ball in the frame reference of the train, that will be acceleration of ball in horizontal direction, that will be equal to negative of a. Okay. So here I can use that in frame reference of train, this distance is being given that 1.5 meter. The boy has to travel this distance to catch the ball. So I can use the second equation of motion, that is equal to s is equal to ut plus half at square. Okay. So this is the equation I am using for the ball, in frame reference of train, in frame reference of the train. Okay. So here the value of s is being given, that is 1.5 meter, that will be equal to the value of u in the horizontal direction, that we already know, that is 5 meter per second, into time period is root 3 second. Okay. Plus half into, and acceleration of this ball in the frame reference of train, that is negative a. Okay. Into t square will be root 3 square. Okay. So this will be what? 1.5 is equal to 5 root 3 minus half of a into 3. Okay, so here we have to find out the value of this acceleration a. So here 3a by 2 will be equal to 5 root 3 minus 1.5. It is 1.15. So this value is 1.15 actually. 1.15 meter. That is 1.15. Okay. So here the value of this acceleration will be equal to 2 into 5 root 3 minus 1.15 divided by 3. Okay. So we have to solve this value, that will be equal to that 5 root 3 minus 1.15. This is equal to 5 into 1.732 minus 1.15. Okay. So after solving this term, we will be getting 5 into 0 1 5 1 6 1. This is 6 point. Wait. 5 into 2 0 1 1 3 5 4 1 8. 8.660 minus 1.15. So this will be equal to somehow like some 7.5 we can write it. Okay, so the value of acceleration will be equal to 2 by 3 of this 7.5. Okay, so we can solve it like here is 10, that will be equal to 150 divided by 30, so it will be nearly equal to 5 meter per second. So the acceleration of the train, we here got that acceleration of the train is 5 meter per second square. Okay, so this is our answer. We have to check a little about the calculations here that we have to keep in the mind while solving the question. So here is the answer for this question, that is equal to 5 meter per second square.